Hello everyone. In this video, I'm going to demo the y8664 processor with fetch, decode, write back, and PC update stages. So as you can see in this Logisim window, we have one more stage, one more module, which is register file. So it is responsible for both decode and write back stage. Okay, and so it takes all the inputs we discussed in the previous tutorial, and also it outputs value A and value B. So just for running this simulation, I just connected val E and val M with just a constant value over here, F and F, and also condition code for uh, like control module destination E, and condition code to the PC updates with just zero value, because um, um, since we don't have execution unit, so we cannot execute jump or conditional the instruction with condition code correctly. So I just set zero value to this. Okay, and then I made 15 outputs for each register to read register updates. So every time we execute instructions, because this is our programmer visible state. And also I'm using the same program as a test case, which is asum. But in this case, I'm going to run the first instruction, because the later instruction, some other instruction actually need the, the output value from either execution unit or memory unit. So I just execute first instruction, which just move in immediate value in the register to the in the instruction to the register. So we can execute the first instruction. Okay. So as I did in the previous demo, I'm going to tick 10 times, which is the number of cycles we need to fetch instruction. And I expect to see some updates, available inputs to the register file. And if this instruction needs to read register value, then I also expect to see the outputs of this register file on val A and val B. Okay, let's get started. I'm going to tick. Let me reset the simulation, and then tick 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I ticked 10 times over here. And then, okay, let me pull up the machine code as well. So I code and iPhone looks correct, since 3 and 0, 3 and 0. And then RA and RB are 1111 and 0100. Okay, so this is correct. 1111 and 01004. Okay. Then how about inputs to val C is 200. Okay, it is correct. Right? So val 2 is 200. And then in the for the inputs to the register file, so since we don't want to read register file RA, so source RA would be 1111, and then so RB we want to write immediate value, which is 200, to the register RB, not reading. So source B would be also 1111. We don't want to read RB. We want to write 200 to RB. Okay. So then here, so test E, which we will get value C from the ALU, because we need to somehow put this value to either test E or test M. So in our data path design, the val E would have this value. So this value, the val C in the value E. So we want to set this register value RB to the test E. Okay, good. And then all about the test M. So we are not going to write this, the val M to the register test M. So it will be 1111. Okay, so far so good. So then also output of val A and val B. So since we are not going to read any registers, so the output is kind of unknown. So it is up in this case, output of val A and val B can be anything. So it can be anything, like it can output some real value, not the unknown value, like U over here. You can it can be anything. It is the implementation specific, so it should be fine. Okay. But okay, in the next, okay, then I will take next 10 ticks, and then we expect to write the val E to the RB register, in this case 400. Okay, register 400. Actually, register 400 is RSP register. We will see some changes in the RSP for here. Okay. But the thing is, the vals P here is going, it should go to the ALU, and then ALU just outputs val P itself. Then it will be going back to val E to the register file. But since we don't have ALU, so then we expect to write this constant value f to the value E. Okay, good. So then let me take 10 another cycles. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. Okay, I just ticked 9 times, not 10 times, because exact timing of write back is at 19th cycle in my design. Okay, so then so RSP, so we are at cycle 19 or 13 in hexa. So we didn't change RBP yet, but we have a value available in on the val E. So when I just take one more tick, then we will see updates on RSP value over here. Okay, let's take once again. Okay, good. So we see the value f in the RSP value. Okay, this is how we test with a real program with incomplete design. But since register file is really important for your later stages, we need more tests. So then in this case, we need to manually put input values and then see the outputs. Okay, so then you can manually set. I recommend you to manually connect input and outputs with where is it? Some like pins like here, and then you can set this pin number of data bits with 4 because input takes 4 bits, something like that, and then you can have manual like the pins with 14, but maybe hexadecimal value. Then you can freely set input data to val E, and then you can select a register to write using guest E, something like that. Then you can make your own test cases to see how like read and write are working correctly as you expected. Okay, but I'm not going to show you how I'm doing. It's very straightforward for you, I believe. Okay, so this is it for demo of register file, decode and write backstage. So in the next video, we will talk about execution stage. Thank you.